Good afternoon, everyone, and welcome to Aviation 2013. My name is Sandra Magnus. I'm the Executive Director of the AIAA, and I'm delighted to see you all here. This is the sort of one of our forums in practice, if you will. As you all know, we're going to the new event model next year, and the aviation, this is the first time for a conference like this where we've put a couple of technical communities together surrounding the aviation theme, and part of the experience that you'll see this week is a step towards the new event models that we'll be rolling out next year. So I hope that you will find this a very useful conference. There's information being presented to you at all levels, from the technical up to the big picture plenary, and I hope you take advantage of all these opportunities and give us some feedback at the end of the conference and tell us what you liked, tell us what you didn't like, give us some ideas for how we can improve for next year, and then come back next year and see how we implemented your suggestions. I'm going to introduce Mike Delaney in a moment, who will be introducing Jim Albaugh, who's the keynote speaker. But first, I'd like to take a moment to thank our sponsors. Boeing is the premier sponsor this year, and have put a lot of work into helping us frame the conference and some of the great topics that we see here today. For the receptions, we have Gulfstream and Lockheed Martin, who have generously sponsored some of the receptions that we'll see. Also, I have special acknowledgement to Jim Visaka, who has put lots and lots and lots of time and tender, loving care into making this a successful conference. So thank you, Jim, for all your work. And then, yes, definitely. Thank you. You should stand up. Stand up. Go ahead, Jim, stand up. There you go. Also, we have a complex systems analysis course going on, or a conference going on, experience going on here at the same time, and Alan Arrington and Wilson Felder put a lot of time into that as well, for those of you who are participating in that. And finally, Dave Maroney has put a lot of time into arranging the technical part of the conference and shepherding the communities as we've come together to be able to have these cross-disciplinary talks and things like that. So thank you to Dave. So I'd like to now introduce Mike. Mike started in 1985 at Grumman, shortly thereafter going to McDonnell Douglas in 1988, working in flight test and working his way up through the flight test world there, becoming eventually chief engineer of the 737, followed by the VP of engineering for the 747, 767, and 777, and finally in 2010, becoming VP of Engineering for Boeing Commercial Airplanes. And so he's had a wonderful career in aerospace, like many of us, shares the love of things flying. And so Mike, if you'd like to come to the stage.
Good afternoon, and welcome to Aviation 2013. As Sandy graciously introduced me, I'm the executive chairperson for this conference, but I also, in my day job, get to run engineering for commercial airplanes for the Boeing company. As I was preparing for this, I was going to touch a couple things about the conference, and I wanted to just talk about the importance of our industry, the importance of the people in our industry, and also then the importance of this conference and the new event model and where we're heading. So, I was sitting there trying to think about how to have that conversation, and as I was telling some people, I spent the last 4 days in a tent with my 10-year-old Weeblo son, and one of the things at a Boy Scout camp, and I started thinking about, nothing's changed in the Boy Scouts since 35 years ago when I was at Boy Scout camp, and what an iconic institution that the Boy Scouts are, and that they actually did a lot of things that we think we stole from the auto companies called lean. And if you've ever been a Boy Scout and went to the lake and the swim and the swimmer's test and the little tags and buddy system, they had standard work before the aerospace industry ever even thought about it. But it's an iconic institution, an iconic organization, and I think that's the way we need to think about the AIAA and the way we need to think about the aerospace industry, because it is an important industry, both to our communities as well as our economies, and quite frankly, it serves the world really well. And I'm most familiar with the commercial, so if you're in other parts of the business, indulge me for a minute, but thinking about the commercial business today, where we stand, most airplanes look like this Boeing 707, a semi-monocoque, swept wing, jet-powered airplane. And today we only use 2 engines, and they go 8,000 nautical miles and fly 330 minutes over water in an ETOPS mission. But they fundamentally are descendants of the 707. So just like things very slowly change in the Boy Scout, I noticed that the manual is in color now. It was in black and white when I was a Boy Scout. So they've made some movement, and we now have twin-engine airplanes instead of 4-engine airplanes. But there are some iconic things about commercial aviation, and you think about, the 747 is literally an iconic figure known to the world. And I like to say that the economy of the world flies on the wings of our airplanes. But that's looking back, and if you look forward and think about it, we project in our commercial market outlook that there's a need for 35,000 commercial airplanes in the next 20 years in aerospace. That's to replace the existing airplanes and to deal with the growth that's driven by the growth of the GDP of the world. And then to go with those airplanes is a robust service business. And when you add the $4.8 billion for airplanes, $4.8 trillion for airplanes, and $2.5 trillion for services, we're looking at a $6 trillion business just on the commercial side. And that's not even including space and military and all the other parts of this wonderful business we're in. So it is a fantastic business, and it has incredible opportunity, which is why governments and companies and individuals are trying to get into the business. But it leads to the next part, which I think is equally important. What I worry about as the leader of engineering for commercial airplanes is we all know that the backbone and the basis of that economy and the 707 and the 747 and the 787 is really built on the heart and the sweat and the brains of a lot of really, really talented engineers and physicists and scientists that bring the technology and the innovation and the creativity that allows those airplanes to come to fruition. And I think as most of us, are facing, we in commercial airplanes or we in Boeing are a bimodal organization where we have a fairly large group that are heading into the retirement phase. And we've got about a third of the group that's just come in the last 10 years. And we have this enormous knowledge transfer requirement to happen to enable our ability to continue and matriculate this business that we love so much. And so I think a big part of our job as stewards of the industry is to think about developing that next generation of leaders and the next generations of scientists and engineers and mathematicians who are going to lead us and develop the next 787 airplane. And then I'd like to turn, in my opinion, to a little bit about this conference. And as Sandy alluded to, the AIAA is changing the event model, and this is one of the first conferences to sort of use that new event model. And this year it'll focus on Aviation 2013. And as in any change or any undertaking, clearly we're going to have to work our way through the things that are good and bad about the new model. But I think from my involvement, and Jim, thank you again for all the work you put in and the hours I've spent with Jim, I think there's an enormous amount of promise in the new event model that will allow us in the next couple of days to really dig into the issues that are key to the success of our industry, whether it's energy or cybersecurity or unmanned aircraft or markets, and start thinking about the critical policy issues as a product of this meeting that we can then go forward and leverage and really bring the AIAA's value to the discussion. And so my hope is that over the next couple of days, we create some stimulating discussion on many of the panels and policy discussions that you have, and that you're able to bring your talent and capability to the discussion too, and that we leave here really with a working product moving forward that we can then go leverage. And so that's sort of the outline of my expectations of the conference as we see them. And with that, I'd like to turn to introduce to our keynote speaker, who's a very good friend of mine, and I'd like to introduce our distinguished speaker, Mr. Jim Albaugh. And in my personal opinion, there's nobody that I've met in this industry that I can think of that could be a better person to kick off this event. Jim thinks about science, he thinks about engineering, he thinks about policy, and he thinks about how all these pieces go together from defense to a cyber to connectivity to commercial aviation to business reality. And I think that's a perspective that we're going to all enjoy. I had the privilege of being Jim's engineering leader when he was leader of commercial airplanes at Boeing. But let me walk through some of Jim's background that you might not know. Jim was also CEO of Boeing Integrated Defense Systems, the defense and space side of our house. Prior to that, he was CEO of Boeing Space and Communications. He was also past president of Rocketdyne Propulsion and Power. Jim is also an honorary fellow of the AIAA, as you all know. He's a fellow of the Royal Aeronautical Society, and he's an elected member of the International Academy of Aeronautics and Astronautics, and serves on the board of the Governors of the Wings Club, and is a trustee of the Willamette University, his alma mater. Jim has also received numerous awards and honors, including the Forrestal Award in 2010 from the National Defense Industry Association, and the Howard Hughes Memorial Award in 2008 from Southern California Aeronautics Association. Semper Fi Fidelis Award in 2006 from the Marine Corps Scholarship Foundation. And so with that, I'd like you to help me welcome Jim to see his insights and listen to him and enjoy his speech. So thank you very much, Jim.
Thanks, Mike. Okay. Well, good afternoon, everybody, and thank you, Mike. Real honor for me to be introduced by one of the finest engineers that I think I've ever worked with. What's great about being here today is I'm not talking to a bunch of politicians or a bunch of Wall Street analysts. I get to talk to 500 engineers, and that certainly is a pleasure for me. I think we're in the world's greatest profession. The job of engineers is to make the world better, and I think that's what we do. And I get a chance often to talk to young people that are thinking about going into engineering, and I talk to them about why it's such a great profession. And as you well know, it's not about the analysis, it's not about the calculations, it's not about the laboratory or the simulation. It's about the mission. And there's nothing that makes you feel better than standing next to somebody like Mike Delaney when a 787 takes off for the first time, or standing next to Pat Shanahan when you do a missile defense intercept for the first time, or you're down at Stennis and you're running a rocket engine for the first time along with Rick Bailey and some of his engineering team. It's extraordinary, what we do, and we're certainly very lucky to be in this profession. In aerospace, I think is a fantastic industry, and it really is a force for good in this world. We drive the world's economy. We're great stewards of the environment, and I think we've been able to bring together and connect cultures and countries and people that have never been connected before. And today, the United States is the leader in aerospace. We build the best and the most capable commercial airplanes in the world. Our defense products and our satellites are remarkable. They're second to none. And until recently, our manned space program was also second to none. It's unfortunate that we're no longer a spacefaring nation. But I'm concerned and I worry that our leadership in aerospace is threatened. And with that threat, I think comes an issue potentially with our security, our economy, and also the future. And I believe that we as a country really need to step up to this challenge. And I fear that the benefits that we have had as a country that have flown from aerospace could leave our economy weaker and our nation less secure than it is today. I spend a lot of time in Washington, D.C. still, and I don't hear an awareness of what's at stake in this country, a sense of what's required to do as an industry or as a nation, and I don't see a commitment to act before it's too late. Other countries are investing very aggressively in aerospace and defense, and we're doing just the opposite. We're worried about what to cut as opposed to thinking about how to grow. If one looks at the Pentagon, potentially they're facing a $1 trillion or $500 billion reduction. And in my view, it's probably going to be more than that. While competing nations have clear goals and are executing on those goals, we're letting our industrial base atrophy. We're pushing our research and development dollars overseas. We're allowing our infrastructure to decay. And we're losing, I think, critical capabilities. And we do that all at our own peril. Now, like many of you, I was fortunate to join the aerospace industry in the last quarter of the 20th century. A very exciting time to be in this great industry. You know, we got a chance to do some wonderful things. And if you go back a little bit further than that, you think about the aerospace industry and how it really defined, in my view anyway, defined the 20th century. Helped win the Cold War. Certainly it won World War II. It brought the world closer together with commercial air travel. And of course, it changed how we look at the world forever when man first walked on the moon. And I think that aerospace can and will define the 21st century also. I think the question is, will it be American aerospace? I hope so, but I don't think that's a given. And for those of you that think I'm being alarmist here, you know, if they had a meeting here 40 years ago and a similar speech was given, I don't think anybody felt that Airbus would be the force that they are. Make no mistake about it, Airbus builds very, very good airplanes and has half of the market. So let's start by taking a look at the great industry that we work in. You know, first of all, it's vibrant, it's challenging, and it's rapidly changing. You know, looking ahead, as Mike said, we have real potential. 35,000 airplanes over the next 20 years at a $4.5 trillion market price. And if you look at how that mix is going to change, if one goes back 20 years ago, about 70% of the airplanes that were being bought by North American and European customers. You go out 20 years, and only 30% will be bought by European and North American customers. The world's changing. The developed nations are buying a lot of airplanes. The traditional duopoly between Boeing and Airbus is certainly going to be challenged. You don't have to tell you about what's happening in China with Comac, with Bombardier in Canada, in Brazil, and certainly also in Russia. And I don't believe all of those entrants will be successful, but I think there's a very good chance that at least one of them will be. And as a result, I'm not certain that our legacy is one that's going to be guaranteed. Leadership is about making the right decisions, and making the right decisions in good times and bad. You know, it's interesting with the economies in Europe and elsewhere being what they are, very challenged. And what we're seeing is that the government leaders are turning to just about any source they can for additional revenues. And increasingly, they're turning to aviation. We're seeing policies that tax air travel. We're seeing money diverted away from critical infrastructure. Those of you that flew into LAX and you compare that to landing in Beijing or landing in Singapore, there's a marked difference. We have different regions of the world imposing different kinds of regulations, inconsistent regulations, which drives cost up for the airlines. And this is a burden that's being put on an industry that hasn't made a lot of money over the last decade. I think that the airline industry has lost money 6 out of the last 10 years, although they're having a good year this year. So if the goal that we have as a country is to grow our economy and improve our world, and the policies that I just talked about are moving us in the wrong direction. If you want to create jobs, if you want to drive the economy, aviation is part of the answer. Our industry is one of America's greatest exporters. The Boeing Company is the United States' largest exporter. Aerospace supports millions of jobs, not only at Boeing and Airbus, but at suppliers, airlines, and airports around the country. Globally, aerospace supports some 56 million jobs and contributes $2.2 trillion in economic activity. And if you add up the cost of all the goods that are delivered by air, it's about 35% of all international trade. Now let me talk for just a second about what the industrial base means to our country. The industrial base was the arsenal of democracy that equipped us to win World War II and the Cold War. The arsenal also put man on the moon, and it made the United States a worldwide leader in space, communications, and defense, and commercial aviation. But a strong industrial base is not a given. It's a product of the right policies, investments, priorities, and I think probably most importantly, it's a product of time. And the question is, with our current direction, do we risk breaking a continuum of capability that has taken us decades to build? In my mind, to be a viable contractor, and to be a Boeing or a Lockheed or a Northrop Grumman or a Raytheon or a General Dynamics or a Bombardier, any of the prime contractors, you have to understand how to do R&D. You have to understand how to take R&D and transition it into production. You've got to run a healthy production system. You've got to support the fielded hardware that's out in the marketplace. And it's really interesting that what we're seeing is that continuum that I just talked about, taking things from R&D, all the way to support. We're breaking that continuum. On the defense side, there are going to be very few new starts over the next decade. Believe it or not, for the first time in probably 100 years, there are no active design teams. And in my mind, the F-35 is done. It's in flight test. And it's a question, in my mind anyway, how soon we'll do the next airplane for the Department of Defense. So we're losing our capability to transition design into manufacturing. And once you break that continuum, it's going to be very hard to recapture it again. And just a case in point, I think one of the reasons that Boeing was challenged on the 787 is we had not done a development program since the 777. We had forgot to an extent how to take detailed design and transition that into production. I fear that our country one day will wake up and they will ask for a capability, and what we'll find is none of the prime contractors remember how to do it. I find it troubling the direction that we're taking in space in our industry. The demise of our space shuttle program is going to cost thousands of very experienced engineers their jobs. We've seen thousands of them transition into other areas of engineering. And without clear direction and investment, I think we're going to lose the intellectual capabilities that has taken us some 50 or 60 years to develop. And it's interesting, just when we're seeing the payoff from the International Space Station, we've been reduced to hitching a ride to the International Space Station with the Russians. And for the first time since 1962, we don't have the ability to put an American into space in an American launch vehicle. And what I find very ironic is that when Russia was penniless, let me say the Soviet Union was penniless, they kept their space program alive. And the irony is that the United States helped them. We had the Shuttle Mir program, we had the space station program. We did a lot to sustain their space program, and today, ours is gone from a manned spaceflight program, and we're dependent on them. So for the first time in years, we have no mission, we have no dream, and what I'm concerned about is we really have no leadership for space in Congress. And while we're seeing some good momentum commercially, I don't think it's any substitute for what we're giving up. Let me talk about the sequester, if I could, for just a minute. A lot of people don't think we're going to be impacted by the sequester. To me, it's like a snowball rolling down the hill. It starts small, gets big. But if you go back and you look at the revenues from the defense contractors since 2011, they've shrunk. The revenues have shrunk every year, and they will continue to shrink. And of course, they all talk about this great market they have internationally, but all the contractors are competing for the same contracts. They won't all be successful. A recent AIAA study, and I would guess that Marion Blakey will talk about this tomorrow, says that if the sequester goes to where it could go, it could mean 2 million jobs, and these are 2 million very high-paying technical jobs and support jobs. And sequester will affect the big companies. It'll affect the Lockheeds and the Northrops and the Raytheons and the others. But these are cuts that will go across the supply chain. And my guess is the large contractors, in order to mitigate the impact to them, will start pulling work in for the subcontractors, which will exacerbate the impact on the level 1, level 2, and level 3 subcontractors in their supply chain. I think that's why it's important that our government, address these budget issues in a very balanced way. And I think that preserving the industrial base requires a lot more than just preventing the cuts. What it really requires is a strategy. In most every country in the world that's serious about sustaining their industrial base has a policy, an industrial-based policy. And when it comes to our policy here, we have one in the Department of Defense that says market forces. Now, I'm not quite sure what that means, but I think what it means is if there's not a market for, say, a new satellite of a certain kind or a transport airplane of a certain kind, it's okay for that capability to go away. I found it interesting when I was peddling C-17s in the Pentagon. They'd say, don't worry about the C-17 going away. The Boeing company builds big airplanes. You can build a big airplane if we need one in the future. And I always pointed out to them that the contractor in the world that built the world's biggest airplane, Airbus, which built the A380, was struggling with another big airplane called the A400M. So sometimes the commercial to defense equation doesn't translate quite as easy as a lot of people think it might. So I think we need a policy, and we need to start a dialogue in industrial base. And I'm not advocating that the government buy things they don't need, and I'm not advocating that they spend money on things that are frivolous, but I think there needs to be a dialogue on what are the technologies that are necessary that we keep alive in the event that we need them. For instance, how can we support some limited design teams to support specific technologies that we know are going to be necessary in the decades behind? We have not even had that conversation, and we need to start that dialogue. I think part of the strategy for an industrial base also includes, having a level playing field across the Atlantic and a level playing field across the Pacific. The United States and Boeing won a very important victory in the WTO Airbus trade case, and I worry that victory is going to be one that's just a paper tiger, a paper win, unless it's backed up by strong and swift enforcement. To me, anything less than that devalues the WTO and devalues a rules-based trading system that we fought so hard to establish. We also need to continue to invest in research and development, and where R&D goes, innovation and economic growth follows. More than half of America's GDP is due to technology and the innovation that it provides. Yet, the U.S. government's R&D as a percentage of our GDP has fallen to about 60% of what it was in 1964. And by contrast, R&D investment in China is the fastest of all the advanced countries in the world. Clearly the U.S. government plays an important part in supporting research and development. In my mind, the role of the government is to invest in high-risk technology, that type of technology that companies want to invest in because they can't see the near-term, or for that matter, sometimes the long-term payout. I think a good example of that would be the Wave Rider, the hypersonic airplane that recently flew and was successful. And I think, if I'm not mistaken, and I wish Rick Bailey were here, I think it was successful on the 5th of the 5 vehicles that they were under contract to build. I think the big question now is, will there be a follow-on to some of that breakthrough technology? And I think we all know in aviation, and also in space, the technologies associated with propulsion are the ones that we have to invest in if we're going to see a significant change. Another issue on R&D is the R&D tax credit. Our government decides that every year they'll vote on whether or not we're going to have an R&D tax credit in the future. Pretty hard for big companies to plan R&D investment if they don't know whether that investment they don't know how that investment will be treated from a tax standpoint in the years ahead. So my commitment to you is, until there are scientists and engineers run in Washington, I'll continue to go back there to talk to them about how important the work that you do is to our economy and also to our future. Let me talk for just a minute about the workforce, and Mike Delaney touched on that. He mentioned that many of the engineers at Boeing can retire, and the same is true for all the different contractors that are in this room. And many of them can retire within the next 4 or 5 years. I don't think they all will, but they could. And the sad truth is our country is not generating enough scientists and engineers coming out of the universities. And to me, that contributes to something that I've called the intellectual disarmament of our country. And that, along with R&D spending, I think, will put our country at risk. And I think that we have to ask the question, how can we ensure a very strong pipeline of skilled workers? And a lot has been said about STEM, so I won't belabor that. I think we all are working very hard at that. But you have to wonder, why American students aren't embracing engineering enthusiastically, as enthusiastically as they are in other parts of the world. And my view is that in this country, engineers and scientists aren't celebrated to the extent they are, elsewhere. A couple of years ago, I was in Russia, and I was walking around the cemetery that was outside of Red Square. And you walk around and you see the grave sites of scientists or the grave sites of ballerinas and writers, political leaders, admirals and generals. But what I was struck by walking through that cemetery is, right along with those other, people that were so great and so famous in Russia, were the graves of scientists and engineers. Tupolov's grave was there, Ilyushin was there, Sukhoi was there. And it made me wonder, when was the last time in this country that we saw, the picture of a scientist or engineer on the front of a newspaper or the front of a national, magazine? I really believe that young people are looking for the same thing that we were looking for when we became scientists and engineers. Many of us, wanted to support the space race. Many of us were very taken by Neil Armstrong walking on the moon in 1969. And I think young people are looking for the same thing, a challenging career, something that allows them to grow each and every day, and something that they can work on that provides, greater good to the country. And I think we can capture, engineers from future generations by capturing their imagination and painting a picture of them being part of something very exciting, something that will shape the future, not just for them, but for their country and for the world. And just as my generation was drawn to space, I think in the future, if you look at what are the challenges that these kids are going to have, there are many, many compelling missions. Rebuilding this country's and the world's infrastructure. How can we, save the spaceship we're all on together, the planet Earth? The issues of global warming, the issues of energy independence, the issues of healthcare, and how do we paint those missions into very exciting things for kids to do? Now we have some great generation, or some great engineers coming up in the next generation, and we are very lucky to have some of those people with us today. I think many of you know about the Conrad Scholars and the Spirit of Innovation Challenge that we sponsor at AIAA every year. The Conrad Award is named after, of course, Pete Conrad, the third human being to walk on the moon, and somebody that many of us had the opportunity to know and work with. And this is an award that's presented every year by Lockheed Martin and also Battelle Memorial Institute. There were some 230 entries from 44 different countries. There were 20 high schools and their teams that were invited to come to JSC to present some of the innovation that they had come up with. And we have a team from Downey, from Warren High School, and it's ironic that they went down to JSC to win their award when you think about the fact that the shuttle was built right down the road in Downey, California. And what did they come up with? As I told them earlier today, their innovation may be as remarkable as the 787 Dreamliner. They've come up with a system that'll put you to sleep the minute you step on that airplane and put on the contraption that they invented. So what I'd like to do is invite them up here so you can give them a big hand. From Warren High School, Mullen McDougall, and also Matt Pachenko. Could you come up along with Coach Glenn Yamasaki? Please come up. Okay, thank you. I don't think they brought the resumes, but I'm sure that you can fight over them in the hallway in just a minute. Thank you. Before I close, let me talk on an issue that I think is very important to the future of aerospace. And we all know that growth in our industry or in any other can't come at the expense of the environment. And that's why Boeing and Airbus are working so hard to reduce the emissions coming from their airplanes. And that's why all of us support a 21st century next generation air traffic management system. You think about commercial aviation today, it contributes about 2% of all the CO2 emitted into the environment. And air travel will double over the coming decade. And we need to do more to reduce that impact. Globally, our industry has set some targets for carbon neutral growth by 2020 and a significant reduction in CO2 emissions by 2050. And if you talk to the airlines, other than safety, the top two issues they have to do with profitability and their environmental footprint. And both of those equate to the same thing, the efficiency of the airplane, the efficiency of the engines, and what the CO2 emissions might be. If you take a look at the operating costs of fuel, 40% is the number that you'll be quoted by most of the airlines. So they're very intent on driving that number down, and they're very intent on reducing their environmental footprint. I know Boeing is very committed, along with the other OEMs, to work as hard as they can to improve the aerodynamics, to improve the efficiency of the engines, and also to make the materials that they use more lightweight and more efficient. A benchmark that we used at Boeing was that about 75% of the R&D that we spent was specifically targeted at technologies that will reduce the environmental footprint. Our industry has never waited for the government to tell us what to do relative to emissions, and I think we need to get out ahead of the regulators and demonstrate to them what the art of the possible is. One of the things that I wish they would step up to a little more aggressively is the next generation air traffic management system. Boeing and Airbus have spent billions of dollars to make two airplanes 20% more efficient than the airplanes that they've replaced. Just think about a next generation air traffic management system. A space-based air traffic management system could make every airplane that fly 20% more efficient than it is today. And we need to try to move in that direction. And I think about my lifetime and what are the three real breakthroughs in transportation that I've seen. First, the interstate highway system was one. Commercial air travel was another. GPS was a third. And next generation air traffic management really could be the interstate highway system of the sky. And I think we all need to push our government figures as hard as we can on that. And I thought it was interesting, several weeks ago, President Obama talked about the environment, and what he talked about were regulations. I wish he'd talked about air traffic management. He had a great opportunity to do that. And to me, if we're ever going to have an air traffic management system that can move us from where we are to where we need to be, it is going to take a significant investment by our government. Throughout my lifetime, aerospace has really defined our country. It's improved our country in countless ways. The U.S. has always led the pack, and I think that AIAA can be a voice as to how we can continue to lead the pack in the future. And I think that it's the job of AIAA to provide that leadership, and over the next several years, working with Sandy and the rest of the leadership team of AIAA, I hope to do that. Thank you. Now, I think Sandy told me this is the time I'm supposed to ask for questions and answers. Now, ask for questions, and I'll give the answers. I'll try to. So I'm faced with 500 engineers out here, all with riveting, penetrating questions, so have at it. Got one in the back there.
You listed a bunch of challenges coming up for us as the next generation in the future. What suggestions would you recommend to us to start influencing the next 20, 30 years that we personally start working on to help those challenges?
Well, I think every company it's incumbent on every company to be thinking about, what the future is. And the way that I think strategy needs to be done is to look at the competition. It's to look at technology. It's to talk to customers and figure out how you can provide them, better capability. You think about commercial airline customers. What do they want? They want efficiency. They want range. They want payload. They want a pleasant environment for the passengers. And how do we invest our technology dollars in order to do that better than the competition? If you're a defense contractor, how do you provide a network-centric approach to provide situational awareness inside the decision loop of whoever you might be having an issue with? I think it's incumbent on us to figure out the future for the customers that we have. Relative to the government, and I'll get this a little bit wrong, but the last time I had this fact checked for me, I think there were only 2 or 3 engineers in Congress. And I think we need to spend a lot more time up on Capitol Hill, talking to them about how important what we do is. Yes, sir, right in front.
How might we turn up the heat on next gen?
Well, and I've spent a lot of time over the last couple of years, trying to work that. It was disappointing in that the acting head of the FAA, who testified to one of the budget committees, I think 2 weeks ago, talked about the fact that the funding that he sees over the next 5 years is going to be insufficient to make much of a dent. And I think we've got to paint the next generation system in the context of how it's an investment, and how it's going to make us energy independent, how it's going to make our airlines more competitive, how it's going to do all those things that are so important to the administration. There is nothing that I can think of in our industry that does more for the environment than next gen. We're knowing where everything is in space and time and doing it in an interconnected way. I think we've got to tell that story. And I think it's one of the jobs of AIAA to tell that story. Okay, I look forward to talking to all of you over the next several days, and I hope we have a great symposium here. I know we will. Thank you.